Okay. So far, we have learned how to change a quadratic expression into its completed square form. Okay? But other than being able to do this, we need to have another skills, or we need to have another knowledge so that we can solve quadratic equations using completing the square. Okay? And the idea is very simple. Okay? If, now you think, if there is a number, Jesse, if there is a number after being squared is equal to 9, what is this number? 3. Okay, very good. If we were to write what I say just now into mathematical symbols, it will look like this. I have a number after being squared, it is equal to 9. Darren. Okay? This is exactly what I was saying just now. There is a number after being squared equals to 9. And then you all know that this number is actually 3. Okay. Again, why is this so? It's because on the left hand side, how can I change from x squared to x? Actually, what I'm doing is I'm taking square root. Okay? The square root will cancel out the square. That's why my left hand side becomes x. Okay? And in equations, I can do anything as long as I do the same thing. So if I square root the left hand side, when I square root the right hand side, they are still the same. Okay? But here, there is one thing that you need to take note of. X not only can be 3, x can be another number. Yes. Yes. X can also be equal to minus 3. Because when minus 3 is being squared, minus 3 times minus 3 is also equal to positive 9. Okay? So when we take square root on both sides, we must remember that it can be positive, it can be negative. Okay? So when we take square root here, this is very important. Okay, Ken? So, with this knowledge, you will be able to start solving quadratic equations already. If the quadratic equation ends up to look like something like this. If I have 3x minus 1 whole thing inside a bracket being squared equals to 4. Cannot go asleep already. Okay. If I have this bracket after square is equal to 4, by the same reasoning, I can take square root on both sides to remove the square. Okay? Then I will take square root here also. But I must remember it can be positive, it can be negative. The square root will remove the square, then I'm left with 3x minus 1 equals to square root of 4 is 2. Okay? So 3x minus 1 can be 2, 3x minus 1 can be negative 2. Okay? Then Making x the subject, I will add 1 on both sides. X equals to 1 or x equals to negative 1/3. So you will still be able to solve a quadratic equation and get both the answer. Okay? So putting this idea together with what we have learned, completing the square, let us take a look at one example. For those of you who have your textbook, the example is on page 44. Why you need to go toilet together?
Oh, she also going out. Yeah, I'll meet you.
What fun things are you all doing at the toilet?
So I wanted to say, I wonder what fun things they are doing.
Okay. So now, let us see from the start to finish how you can use putting the two skills that you have learned together and solve a quadratic equation. Okay? So in this question, first they tell you to express x squared plus 6x minus 7 in the completed square form. Okay? So a bit of revision on how to complete the square. Robin, put away your handphone. Okay, x squared plus 6x. So if we were to write this in the completed square form, right down at the side, how it will look like? Definitely it will be x plus how many? 3. Okay? Because 6 divided by 2, we can get 3. Okay? But if we were to expand x plus 3 squared, we will need a 9. So we don't have a 9. So what we need will be a plus 9 and a minus 9. Plus 9 and minus 9 back. Okay? So x squared plus 6x minus 7 is the same as x squared plus 6x plus 9 minus 9 minus 7. Okay? And we know that these 3 terms is actually the expansion of this bracket. So we can write this as x plus 3 squared minus 9 minus 7. They are all numbers. We put them together, it will be minus 16. So this is the answer to part 1. We have managed to write the quadratic expression in the completed square form. Okay? Then part 2 of the question. Okay, part 2 of the question, they tell us that x squared minus 6x minus 7 is actually the same as 0. So now we have a quadratic equation already. And in part 1, your eyes not good or my eyes not good? Oh.
The 6 for the 6.
Eh?
Square plus 6.
My eyes not good, sorry. I old already. Okay. So in part 2, they tell you that this quadratic expression just now exactly the same expression is actually equals to 0. But in part A, we have already managed to write this in this form. So if we want to solve this equation, can you see that this left hand side is actually the same as this? So I can write this as x plus 3 square minus 16. In part A, we already proved already. This is this. If we were able to write this in the completed square form, next step, I can move this number to the right hand side, right? By adding 16 on both sides. Okay? Then next, if this whole thing being squared is 16, I don't want the squared form, I want the square root of it. Then I can square root my right hand side also. Okay? The square root cancel out the square, I'm left with x plus 3. Square root of 16 is 4. So x plus 3 is equal to 4 or minus 4. Okay? Next. Then very simple already. X plus 3 equals to 4 or x plus 3 equals to negative 4. X plus 3 equals to 4 minus 3 on both sides. X equals to 1. Or minus 3 on both sides. X equals to minus 7. Then I have my two answers to the quadratic equation. Okay? So as long as you are able to complete the square for your quadratic expression, you have one more method already to solve quadratic equations. Okay? Now let us try. Try it yourself part-time. Now try this question. Do part A first, then do part B. Okay? Try. Yes.